looking at a lesson 11.3, analyzing geometric sequences and series. So yesterday we had arithmetic sequences and series like this one here in red, right? So to get from term to term, right, we had that common difference of +3, +3, +3, right? Common. It was always the same. If we graphed it, it would be linear. It would have a slope of 3, right? For today's lesson, analyzing geometric sequences and series, we have not a common difference, and we're not going to use addition and subtraction to get from term to term. We are going to be using multiplication. So, right, so we would have, finding any term of a geometric series can be found with the following formula. We have our term is equal to first term, right? So this is first term times r, which is our common ratio. So looking back at that previous example, we had 3, 12, 48. We had a common ratio of 4. We would multiply by 4 to get from term to term, right? Times 4 times 4 times 4. Right, next term would be 48 times 4. Right, that's our common ratio. So that is our generic formula. First term times common ratio to the n minus 1 power. So if I want to find the 8th term, I'm going to take the common ratio to the 7th power, right? Because I already have that first term accounted for. So we are going to set these up using that formula. So find the 6th term. So our n value is 6, right? Term 6 is equal to first term times our common ratio to the n minus 1 power, so 6 minus 1 power. I would probably mental math the 6 minus 1, right? But I have -3 times, I don't even need that, multiplication times 2 to the 5th power, right? For an answer of 96. Right, and I can kind of check that on my calculator. If you space out and you don't have the formula in front of you, you could go -3, enter, and then times -2. So this would be my second term, third term, fourth term, fifth term, sixth term. So for our next example here, they do not tell us the n value that they're looking for. They're actually telling us specifically write the equation, right? So we don't have a specific term. They don't even tell us our common ratio. So I can just do second term divided by first term, right? So 10 divided by 5 is times 2, right? Common ratio of 2, right? They're all times 2 all the way across. So I'm going to use that same generic formula. Any term is equal to first term times common ratio to the n minus 1. And when we're just writing the equation, it's very simple, right? We fill in the little bit of information that we have. I know first term is 5. I just found my common ratio is 2. And I'm going to leave that to the n minus 1 power. And that's as far as it can go. Example B here is even simpler. They tell us specifically what A1 is. They tell us specifically what R is, and then to the n minus 1 power. Right, so writing the equations are pretty simple. So yesterday's lesson, we were dealing with missing terms in our arithmetic sequences. Today, we are dealing with missing terms in our geometric sequences. And yesterday, they were called arithmetic means. And today, they are called geometric means. Those are the terms between other terms in a sequence and can be found by using common ratio R. So here we have an example. I have a first term of 3.12, 3 and 12 hundredths. I have a last term of 49 and 92 hundredths. So what I'm going to do is I'm going to divide to find that larger ratio. So I'm not at my common ratio yet, just this ratio to get from our first term to our last term. So first term times 16 is going to give me my last term. And now I need to partition that smaller or that big jump into 4 smaller jumps, right? 3 lines, but we have 4 steps involved to get from our first term to our last term. And what I need to do instead of division, right? I've already done division. I am going to take the 4th root of the 16. So the 16, my overarching ratio, I'm going to take that to the 4th root here because I have the 4 jumps. I can enter that into the calculator by entering that 4 in first and then going to math, number 5, 16. I could also say 16 to the 1/4 power, either way, 2. So I have a common ratio of 2. Filling in those missing terms then, 3.12 times 2. Those are my missing values right there. 6.24, 12.48, and 24.96. So finding a partial sum of a geometric series, we have a couple of different formulas for finding those, depending on what information is available to us. So if we know our first term and our n value, these 2 formulas here are the way to go. And if we know our first term and our last term, we can use this equation here. So we have to make that decision based on what information is presented to us. So looking at our examples for that, right? And in example A, I know our first term and our n value and our r value. So I am going to use that first formula set given to us. I'm going to use these right here for our first, I'm going to use this for our first example. So Sn is equal to A1 times 1 minus r to the n power. To the n power. Not a very good n there. Okay, over 1 minus r. So I am going to say, if I want to know the 10th term, the sum of the first 10 terms is equal to first term times 1 minus r to the n power, all over 1 minus r. So I am going to then have a -2 on the bottom. And then for my numerator, I am just going to type that into the calculator. 2 times 1 minus 3 to the 10 power. -118096, 118,096. And then my last step is to divide out the -2 for a sum of 59,048. For my second problem, I am told the first term and the nth term and the common ratio. So I am going to use that formula the second formula that was presented to us, a1 minus an to the r power over 1 minus r. So I don't really know what that n value is. I could do some work to figure it out, I suppose. But I am going to say first term 2000 minus nth term of 125 times my common ratio of 1/2 all over 1 minus that common ratio. So I'm going to have a denominator of 1/2 or 0.5. My numerator, I am just going to type in to the calculator like that. 1937.5. And then when I divide out my denominator, final answer of 3875. Right, so a lot of just application of formulas. Formulas will be available to you on your Chapter 11 test. So you should just be familiar with how to use those formulas, and you don't have to memorize them. So that is it for our lesson on geometric sequences and series.